Hello everyone. So today we are going to take a look at a particular situation that involves a comparison between three types of lighting options currently available in today's market. I will be demonstrating some simple and fundamental business practices, and with these techniques we will be able to see our financial impact in both the long term and short term. As stated, the topic for today is lighting, but not just any lighting. It is my intent to look at the consumer's options for illuminating their everyday household fixtures. The first of the three options is the LED or light emitting diode. The LED is very efficient and conservative when it comes to energy consumption. However, it has a fairly high unit cost compared to the other two bulbs. My goal is to show you how these costs behave over a period of time. The second lighting option that will be evaluated is the compact fluorescent light or CFL. Note this table represents the same data that was present for the LED, and more importantly, the figures that will be used later on in this video, which are the unit cost, lifespan, and power usage. And finally, we have the third option, which is an incandescent bulb. Notice the table row labeled equivalent use is blank. This is because the incandescent bulb is used as a benchmark or a starting comparison for the other two options. Since the incandescent bulb is opposite of both LED and CFL, being extremely low in unit cost but lacking efficiency, we use its specifications as a reference. Now that you have an idea of what is being compared, I will discuss why and how this will be done. The why? Well, it's simple. Save money. For most of us, we think, buy whatever keeps the most money in my pocket today. And that philosophy may occasionally work. However, I will show a different perspective on saving by analyzing the long-term effect of our present decisions. As for the how, I will compare the cost of usage for each lighting option over a period of 24 years, including the unit cost per life cycle, and put these values in terms that represent the cost today, or net present cost. Here, this slide shows the cost per kilowatt hour currently being offered in Phoenix, Arizona. By using the light's power consumption and lifespan, a cash flow diagram is constructed. Each diagram shows the costs incurred by both the amount of kilowatts drawn by the bulb along with additional replacement cost as each life expectancy is met. The cash flow diagrams show each bulb as if it were powered for 2 hours a day at a length of 24 years. Since each bulb's operational costs are different, as well as their unit costs, the charts decrease independently of one another. And now that the cash flow diagrams are complete, we can begin to look at the present cost or value of the long-term outcome. Again, what the calculation essentially does is takes incremental costs over a span of time and summarizes the data into an equivalent number that represents today's value or cost. This analysis is what allows the potential total savings to be viewed, not only taking into account the initial expense, but summarizing how that initial expense decreases or increases in value as a function of time. Again, allowing the broad perspective to be viewed. In this slide, the net present value equation is represented. As you can see, the payment represents the bulb's power consumption, and the rate represents the cost per kilowatt hour determined by the electrical company. As the payment amount increases, as does the net present value, assuming a constant rate is provided. At first glance, you will see the trend that a lower operational cost will produce a lower net present value. This assumption is correct. However, after accounting for the unit cost over each lifespan that has expired, the net present value will shift in a negative direction. Since the unit cost is not incurred at each individual point, it must be calculated separately and then factored into the net present value computed. Once this is complete, a final representative solution will be produced and a comparison can finally be viewed. Graphically, we can see how the results play out over the 24-year timeline. Although incandescent bulbs has the lowest initial cost, over time its financial impact is far greater than both CFL and LED options. This means the net present cost will show this timeline in a present value. Looking at the CFL and LED options, the graph shows their overall cost being fairly close. Since this is the case, additional factors may need to be investigated and considered, such as unit cost increasing or decreasing, any technological advances that may occur between the two, or the cost per kilowatt hour fluctuating. Finally, after all calculations have been made, graphs and charts completed and analyzed, a conclusion can be drawn. Based off of all the data presented, it is my suggestion that an LED is most cost-effective in this current situation. This conclusion only holds true when adhering to the values provided in this sample. Although, as you can see, with some minor adjustments to these values, a more specific and applicable scenario can be created in order to see which option best suits your own personal needs. Furthermore, it is important to know that certain assumptions were made in order to complete this sample comparison analysis. First, the Greater Phoenix area was chosen to sample their electrical costs. Since the area is densely populated, I found the region to be a suitable candidate with a higher operational cost than most. Second, in order to keep a valid representation, the size, shape, and color temperature of all three options were identical, if not extremely close. Also, only the most well-developed and known manufacturers of the bulbs were chosen, and sample costs were drawn from a major home improvement store. These costs were then averaged to provide a single unit cost for each bulb. Third, the usage cost was set at 2 hours per day. Note that if this time were to increase, the net present value would greatly change due to an increase in consumption of both electricity and the additional units expiring. And this concludes the comparison analysis. I hope that it was both informative and helpful and possibly can be utilized in your future. And now that the cash flow diagrams are complete, we can begin to look at the present cost or value of the long-term outcome. Again, what the calculation essentially does is takes incremental costs over a span of time and summarizes the data into an equivalent number that represents today's value or cost. This analysis is what allows the potential total savings to be viewed, not only taking into account the initial expense, but summarizing how that initial expense decreases or increases in value as a function of time. Again, allowing the broad perspective to be viewed.